Hello, I'm Ricardo Torquato from the University of Campinas in Brazil, and I'm here to present this work named Practical Chart for Harmonic Resonance Assessment of DFIG-Based Wind Parks. This work was published on IEEE Transactions on Power Delivery, and it was done by myself and my two colleagues, Andres and Walmer, from the University of Campinas, Brazil. Doubly-fed induction generators are currently the most common generation technology in wind parks, and their presence can decrease the damping of harmonic resonances in the park, so it can lead to more problematic harmonic resonances. And the main problem is that the techniques to analyze these resonances currently, they require very detailed modeling. They are mostly based on electromagnetic transient simulations, which require very detailed modeling of the components, requires a very specialized professional to conduct and analyze these simulations, and also demands a very high computational cost. So our approach here is to try to develop a simplified method that can help engineers have an initial idea on whether there is a risk of resonance in the park or not, based only on analyzing a figure, a graphic. So here is the graphic that we propose. The idea is for engineers to analyze if the wind park operating condition is in these gray regions, which are problematic regions, or outside of them in the white area, which is a safe region. If the wind park is inside one of these regions, you can immediately determine that there is a risk of harmonic resonance in this park. So it should be analyzed in more detail, maybe with more detail than electromagnetic transient simulations. Otherwise, if the park is out of the region, here there is no need to do any further analysis. There is no risk of harmonic resonance in this case. And the main contributions here is that this chart can be obtained analytically based on simple derivations which are presented in the paper and without any computer simulation. So you don't need to run any computer simulation, and this is very important. It can save significant time for the engineers that will use it later. And the other important point of this graphic is that it is based on information that is available in practice, such as the wind park capacity, the amount of reactive power compensation with the shunt capacitor that is connected in the wind park, and also based on the short circuit level of the background grid. So this type of information is readily available, and it's therefore easy for the engineer to obtain the chart analytically and also to consult the chart using only information that is available. Here we present three potential applications of the chart. The first one is to determine the maximum allowable wind park capacity that can be connected in a specific grid location. The second application is to determine what is the percentage of time that the wind park will be inside these problematic regions. Knowing this percentage of time, you can determine the overall risk of resonance in the park. And the third application is to help size the capacitor banks that will be installed in the park. You can determine here safe ranges of capacitor sizes that will not cause any harmonic resonance concern. In conclusion, in this work, we propose this graphical method for a quick assessment of the risk of harmonic resonances in DFIG-based wind parks. This chart can be obtained analytically and consulted by using only information that is readily available in practice with no computer simulations required. So this is a very important point of this method. And in addition to analyzing the risk of resonance, we have seen that this chart can be used for other applications, such as defining the size of the shunt capacitor banks and also determining the maximal allowable wind park capacity in a specific location. Thank you very much.